Section 5 talks about logarithmic functions. We studied exponential functions really since the beginning of Chapter 5, so this is a different type. We'll talk about graphs and more specifics, but today we're going to try to get down the basics. This video is mostly going to focus on a log with a base of b, and that's that little b down here. It's a subscript. The wordy definition is the log base b of y. It's the number to which you must raise b to get y. That seems a little bit confusing that way, but if you look down here, what it really means is b to the x equals y. So we call this the loop-de-loop, but basically what happens is you take the base, raise it to this outside number, and that should equal your inside number. Some of you have seen this before and some of you haven't, but it's really important to get this down. It's kind of as a baseline learning for this section. So let's try a few examples. I'm going to throw an x out here just so we have something to raise it to, but if I do this loop-de-loop, I take b, raise it to the x, and that should be 27. So I can rewrite this as 3 to the x equals 27, and then we know that there x is going to equal 3. In this example here, I'll still put an x here. 2 to the x equals 1. The only way to get 1 with an exponent, we know here x would have to be 0. So the first part of your worksheet will be a lot of examples just like this, just getting the loop-de-loop down and then practicing your powers. You can also solve equations using logs. We're going to use this same exact loop-de-loop. When you rewrite that, you get 3 squared equals x. So x equals 9. Down here we get a rational exponent from video 4. We have 4 to the 3 halves equals x. We know that's the square root of 4 cubed, which is 2 cubed. We end up here with, sorry about that, x equals 8. These can get a little bit more complicated. In this example here, we're going to use the same exact loop-de-loop. This whole 3x plus 1 is your y. So when you rewrite that, you get 4 squared equals 3x plus 1, which is 16, and then you can solve it just like a normal equation. So if we come up here, you'd get 15 equals 3x, and x equals 5. So you may see different things in this spot, but in general, you're going to use the same exact loop-de-loop every time. There are 2 special cases that we need to talk about. The common logarithm, like the invisible 2 when you see the square root, right? We talk about how you don't really need to put that 2 in there, but that's what it is. If there's no base next to a log, you can assume it's base 10. So if there's nothing there, you can assume it's a 10. So here, we would say 10 squared equals x. So x equals 100. The other special case is the natural logarithm, and our number e is going to come back into play here. The natural log, you'll never see an e in here, but that's really what it is. We'll talk about why that's the case in class tomorrow. So in this case, we say e to the 4 equals x. And if you plug e to the 4th into your calculator, you get that x equals about 54.6. This last problem is a little harder. We're just going to do the same thing twice. It's kind of a 2-in-1 problem. You want to start from the outside first. That's the important part. So if we take the outside log and the outside b, we're still going to raise it all the way around to that 2, and we're going to come back to this entire thing. So what we have here is 2 squared equals the log base 3 of x. We can write that as 4 equals the log base 3 of x, and now we need to go backwards. So with this setup, and you'll see this a little bit, so this is good practice, we need to do the loop kind of backwards. So our b is over here. We need to raise that to the 4th, and then that's going to come all the way back to our x. If you want to rewrite it so that your log's always on the left, if you're comfortable with that, that's fine. We'd still get 3 to the 4th equals x. And we can evaluate that, and we know that x is 81. So that's a quick intro to section 5.5. You should have a worksheet in front of you to start working on that. Hopefully you can get through all of that in class today, and then tomorrow we'll pick up the rest of the section.